Hi guys, we're going to be doing a problem that's very similar to the one we did on our quiz yesterday. In that problem we have a pulley, and that pulley is connecting two weights, one of which is on an inclined plane and the other which is just suspended in the air. So the first thing we need to do is look at what we're given. We're given a coefficient of friction. We're given the mass of A and the mass of B, and we're asked for what is the acceleration of the system. So first we're going to start drawing the forces that we have on this system. B is the easiest block to deal with because the only force acting on B is the force of gravity. The force of gravity also acts on A, and it acts directly towards the center of the Earth, so we'll call this guy F of G. This block is somewhere in between being supported by the inclined plane and being in free fall. So that F of G is going to be divided in two directions. We're going to call this guy F of G of X, and this guy F of G of Y. And we label it like that because we have been told by our book that the easiest way to solve these problems is to assign the x-axis to the slope of our inclined plane. So this is going to be our x-axis. This part of G is going parallel to the x-axis, and F of G of Y is going straight into the block or perpendicular to the x-axis. Now, since A is pushing on the inclined plane, we know that the inclined plane is going to be pushing back on A with a force that we call the normal force. The last force we need to add is the force of friction. The force of friction is going to be opposing our motion. In this case, I think our motion is going to be going this way. So our force of friction will be opposing that, and we will write him right here. Now, one of the things that I suggest you do to help visualize this is to draw it out, and this time we're going to draw it out on a nice level surface where this line is our x-axis and our y-axis would be straight up and down. So we have F of G still on this guy. That's counteracted by our force of normal. This is F of G of Y. I have F of G of X. I'm not going to draw in my F of G, which would be somewhere right here, because we are going to actually split him into both of his components, and then we don't need to worry about him anymore. I have my force of friction right here, and my force of gravity on this block going this way. Now, the reason that this is all of a sudden going this way is because of our pulley. And our pulley changes the direction, so it's going to be straight this way and parallel to our x-axis. Next, we need to start solving for some of these forces. One of the easiest ones to solve for are F of G's. F is equal to m times a. We know the acceleration due to gravity to be 9.8. So I'm going to take 3 times 9.8 to find F of G on B. And I find out that that is 29.4 newtons. So I found my first force. My next one is going to be the same thing, except I'm going to plug in the 8 kilograms of A and take 8 times 9.8, and I'll find out that my F of G is 98.4. Now, the next thing we need to do is use two of our equations to split our F of G, which we're going to call our A, into two components. We're going to call those A of x and A of y. Now the two equations we get tell us that the A of x is equal to A, which is the magnitude of this line, so 78.4, A times the cosine of theta, and A of y is going to be equal to A sine theta. So theta is one of the big reasons that we drew it out like this. Theta is measured counterclockwise from the positive x-axis, so theta is going to be right there. I know that if I do 3/4 of a circle, that is 270 degrees. And with a little bit of geometry, we can realize if this is 37 and this is 90, then that means that this is 53 and that this angle is 37. So I'm going to take my 270 and I'm going to add 37 to it, and I'm going to find out that my theta is going to be 307 degrees. And we already said that A is 78.4. So now what I'm going to do is I'm going to plug in 78.4 cosine of 307, and I will find out that my A of x is 47.2 newtons, and I will plug in 78.4 sine of 307, and I will find out that my A of y is negative 62.6 newtons. So far, I found this guy, and this guy. I know, thanks to Newton's law, or Newton's third law, that the force of A on B is going to be equal to the opposite of the force of B on A. So if my block is pushing into the inclined plane with negative 62.6 newtons, the plane is going to be pushing back up with positive 62.6 newtons. So my force of normal will equal 62.6 newtons. And I know from one of my other equations that my force of friction, which we'll call F of F, is going to be equal to my force of normal times my coefficient of friction. So I'm going to take my force of normal that I just found, I'm going to multiply by 0.32. And I'm going to find out that my force of friction is equal to 20.0 newtons. So I have officially found all the forces on my force diagram, and now I can get around to solving this problem. We are asked for the acceleration of the system, so we know that F is equal to m times A again. And if we're looking for A, we need to find two things. The first one I'm going to find is the force. And the total force on this system is going to be the sum of all these forces. We already said that these were equal and in opposite directions, so those are going to cancel out. What we're left with is our 3x forces. So if we think that the box is going to move this way, let's call this side positive, and anything going this way we'll call negative. So I'm going to write negative 29.4 because f of g on b is going this way, which is our negative. Friction is also going to be negative, so we'll have negative 20 newtons. And lastly, we're going to have our f of g of x, and that is our force pulling us this way, and that is our 47.2 newtons. And actually, this equation is going to be going this way, because as written, I will have a negative force, so we're going to be going this way. So if I added all these up, I would get negative 2.2 newtons. This negative just tells me that I'm going in the opposite direction I was expecting to go. So this block is actually going to be being pulled up the ramp by B falling. So negative 2.2 newtons. My mass of this system is going to be 3 plus 8, since those are the masses of my two blocks. So F is equal to 11 times A. I can take negative 2.2 divided by 11 and find out that my blocks will be accelerating up the ramp at negative 0.2 meters per second squared. And remember, the negative just told us direction, so this is actually just going to be a 0.2 meters per second acceleration left. And that would be my answer. Sorry for guessing that we were going to go the wrong way, guys. I hope this helps you understand this problem a little bit. Thank you.